So this was the benchtop prototype that we put together a while back for the temp sensor that's going to go out on the balcony at my apartment. And obviously we can't deploy it like this. This was set up just to check to make sure that everything worked. It's been running on the bench now for a couple weeks. Everything's working well. So I think it's time to actually create a printed circuit board with all of these components on it. So let's get started. Alright, so in this video we're actually going to dive into more of the physical world where we take the temperature sensor and the display that we've sort of benchtop prototyped and start looking at making 3D models of our enclosures and doing printed circuit boards that actually take what we've done in our breadboard form and made it something more permanent and something that we can put together and deploy. So what I thought I'd do to start with is just show you Windy City Lab. So here's a shot kind of looking into our lab. We're located with the Chicago Connectory and the Merchandise Mart here in Chicago. And we have this awesome lab setup. And by the way, if you do become a member of the Chicago Connectory, you get access to this. And so if you're here in Chicago, I would strongly suggest you think about that. Membership here at the Bosch Connectory also gets you membership to 1871. And I believe it runs around $300 a month, and you have the ability to get access to tons of mentors, workshops, and anything related to not only doing a startup, but also moving into IoT and building your own physical product. So this is a shot of Windy City Lab. What I thought I'd do is start with sort of our tools wheelhouse, if you will. And what this is a diagram. Sorry, it's a little busy, but let me kind of walk you through it. First of all, over here on the left, Visual Studio Code is kind of our preferred go-to for a development environment. And Particle Workbench is what we're using now as one of the extensions that goes to the Particle device. And you've seen that before, we've used that, and so I won't talk much more about that. But what I want to do is kind of get into some of these other things. So essentially, there's two main pieces here on the right. There's the PCB manufacturing piece, and that's where we're going to actually create a PCB and put it into an enclosure. And we're going to model our enclosure using various 3D modeling tools, although the one that I prefer and the one that we will go through at some point in some future videos is Onshape. And over on the PCB manufacturing side, I've put a couple of PCB houses. I mean, there's tons of PCB houses out there. PCB Way and Osh Park are two pretty popular ones, Osh Park being located here in the States. But the Volterra V1 and the other mill you may not have heard of before. Those actually aren't PCB manufacturing houses, but they are tools that we can use to actually make the PCBs themselves. And I'll show you some shots of those, and we'll actually do that for our first PCBs before we go out to have our boards made. And then, of course, we have to do an electronic design, if you will, and that involves doing a schematic and a PCB layout and having parts libraries and so forth. My preferred tool is Eagle, and I'll go into why that is at this point. This can change over time. I've used Upverter, and I've used KiCad, and I've used DipTrace, and they all have their pros and cons and so forth, but Eagle is sort of what we're going to go with for now. And of course, Eagle is going to actually produce these Gerber files, which then are going to be used by any one of these devices or houses over here to make our boards. And then coming the other way, all of these are providing design rules and CAM instructions that come back to Eagle so that these Gerbers are generated perfectly for that particular device. And then Eagle also supports 3D modeling, which I really like. So it'll do a 3D model of your printed circuit board, and that's a step file that goes out, and then that can be brought into Onshape, and Onshape can include that in an assembly, if you will, for your 3D model product. And then finally, I actually did this drawing in draw.io. If you haven't heard of it before, I definitely suggest you check it out. It's an extremely powerful, easy to use drawing tool to do drawings just like this, which is great for system design diagrams and other things. And it's completely free. So with that, let's step into a couple shots. So here's a shot of the Volterra V1 in the lab. And we're going to do some future videos. Once we get the board designed, we're going to watch this. We're going to put this all together and get it executing on this device. And we'll actually see a printed circuit board come from this. It's really very much like a 3D printer for PCBs. So what you're doing is you're replacing, right now this is just a probe to probe the height of the board. But you have a different cylinder in here, the cartridge you can put here for silver ink, which will draw out all the traces onto the board. And you can also put in a solder paste cartridge, and that solder paste cartridge will go along and lay down all the solder paste on the board, which is very cool. And then this plate here gets warm or hot, and so this is how we cure the ink. So that the silver ink that is injected onto the substrate stays permanent, and then it is also how we reflow the board. Now the other thing is we also have a Bantam, used to be called Other Mill, which is a CNC machine, and we use these copper plates to carve out printed circuit boards, and we can do 1 or 2 layer with this device as well. But now that we have the Volterra, and the Volterra, by the way, has a drill attachment that will go in and will drill holes for our vias, and then they provide rivets that pop in to actually create the rivets themselves, or create the vias themselves and the connections. So the only thing that we're really probably going to use the other mill for is to actually carve out the custom size of the printed circuit board. So for example, here on the Volterra V1, it has a way to drill, but it does not have a way to cut this to a custom size. So you would be sort of stuck with this size once you're finished. And that's where we can use the other mill to carve that out. We also have 3D printers. So Dremel 3D printers are the ones we have in the lab. Dremel was focused on the education market, and what that means is that these things are really easy to use. So essentially this ends up being my go-to 3D printer right now for doing enclosures because of its ease of use. And then finally, Dremel has just come out with a laser cutter. And so this is the laser cutter all set up, and we have this up and running in the lab. I have to say it is the most beautiful laser cutter I've ever seen. It could be a piece of furniture in your living room. And that is another way for us not only to do enclosures, but it is also a way for us to carve out stencils. And stencils can be a way to apply solder paste quickly and easily to a printed circuit board. So for example, if we carved out a printed circuit board here, then getting a stencil off of the laser cutter and putting it on top and then applying our solder paste is a good process. And again, we'll do a video kind of showing that. Now, when we look at the different EDA tools, there's a lot out there, and this is not an exhaustive list by any stretch, and please don't hold me to all of the pricing on this. Pricing changes all the time. Platforms that they support change, but at the time I did this, these were the numbers that I came up with. So, Autodesk Eagle, which I've already said is the one that we're going to go with, it can be as cheap as free or up to $520 a year, and we'll look at that. What I like is that it's available on all platforms. What I don't like about it is it has a very unorthodox UX and UI. And that's because Eagle has been around for a long time, and in the early days it was very command driven. And Autodesk is now, because they've taken it over, have really made a lot of improvements to the UI and the whole interaction, but it's still got a ways to go. And so that's my downside to it. I'm not going to talk about all of these other than to say that KiCad is also very cool. I've used that and I'm a big fan of that, and I'm also a fan of DipTrace. I've also really been a big fan of Upverter over the years, but Upverter has been purchased by Altium, and I really haven't seen much of any progress or change or improvements or any notifications from them at all. I'm sure I'm on their mailing list about what they're doing and what to expect and so forth. I know there is some stuff out there, and hopefully Upverter will come back big and strong and be that cloud-only schematic design and PCB layout software that I think we would all love to see. But at this point, I just can't recommend it because it just looks dead to me. So the EDA criteria that I use falls into a couple categories. Clearly, one is cost. So, Altium is just, it's just too expensive for my budget and a small lab like we have here. So that's not going to be possible, even though I'm sure I could do everything and more in an Altium-based system. So that does mean that we need to be looking at some of the less expensive products, and so cost is definitely a key factor here for me. Another one is a large community of support. So one of the things is that a tool may be very inexpensive and it might actually do most of everything we want, but if the large community is not using it, then the support is very difficult. And I want to be able to just, if I run into an issue, I want to just Google it. And I want 20 people already posting questions similar and seeing solutions. And if I can't do that or see that, then I'm not going to choose that tool. The third is, of course, every part that I need to go put into a schematic or PCB layout never seems to be in the full set of libraries that are supplied. I'm not sure why that is, but it's just Murphy's Law. And I'm constantly having to create new parts from scratch if I can't find them online somewhere. So this has to be easy in the tool. And Eagle, with their new footprint generation, has a really phenomenal way of doing this, which I'm going to take you through in the video. The other thing is, once you make the printed circuit board, I need to be able to export it to a step file and pull it into a 3D modeling tool of my choice. Now, Eagle, of course, is wanting to push you to Fusion 360. I'm an Onshape fan, but they haven't blocked us from doing that, and so we're able to just export those files and bring them into a 3D modeling tool and actually include our printed circuit boards in our enclosures and see how they fit and so forth. Another one is we need good design rule files and CAM files that we can then generate the right files for a particular PCB house or some of the tools we have in the lab. And Gerber, although it's somewhat of a standard, it appears not to ultimately be a standard, right? And everybody interprets it a little differently. Each of the houses need things in a little different format. And this can be a big headache when you get to actually trying to put something and get it to a particular fab house. And by being able to pull in these design rules and CAM files ahead of time from the PCB house itself is really a time saver in getting everything ready to go. Another one is I do some custom design boards for different things that are odd shapes and sizes. And so I'll model those in something like Onshape and then export it as a DXF file, which then I want to be able to bring into my PCB software and have it actually be the new outline of the board. So typically outlining a board, it's fine if it's a square board, but if it's not, then it ends up being not the best place in the PCB layout software to be sort of creating and drawing this complicated board. It's much easier to do it in another program that's made for that, and then have these DXF files, which are sort of the vector file that describes it all, be imported. And then, of course, finally, I'm a Mac guy, but for my feeling, all of these tools should be available for Mac, PC, and Linux. It's a typo. But my preferable way to do this is to see it just web hosted, and then we're not worried about the platform. So we're going to go with Autodesk Eagle. And to just give you a little idea on cost, this is just a screenshot currently as of April of 2019 on how they cost this out. And what I love here is the free version is 2 layers. You can actually do a lot with just a 2-layer board. So basically you do as many traces as you can on the top layer, and then when you can't get from A to B anymore, you can then jump to the bottom layer and you have a whole new palette where you can do more routing. And it's surprising how going from just a single layer to a 2-layer board, your routing is almost always doable. And so that's great. Now, the next step up is if you want to get to a 4-layer board, and a 4-layer board might be advantageous where you have a ground plane and a power plane. and those would be the middle layers, and then your top and bottom layers are still your routing. Or you can just use them all for routing as well, if it's more complicated. But you can get a long, now you can really go a long way on a 4-layer board. And of course, for completely professional systems where you have up to 16 layers, you can, purchase or subscribe, I should say. There's no purchasing anymore. Subscribe at $520 a year for that. This seems a little excessive for me. This might be an option for me at some point, but right now we're just using the free version. So a couple key things to remember when you're working with Autodesk Eagle. And the first one is when you're doing schematics, keep the grid spacing at 0.1 inch. Don't screw around with it. And I'm just bringing this up because I've seen videos on this and tutorials that Autodesk has done, and they harp on this. So I haven't changed it, so I don't know what happens and how things don't work, but don't change the grid spacing there. When you get into PCB layout, you absolutely can change the grid spacing, and I would recommend that you do that so that it can do all the routing at a finer level. Once you create a board layout from your schematic, you never want to close one without the other. So you always want to keep them both open. And that's so that they remain consistent. And again, if you don't do this, there's going to be a big banner that's going to warn you about it. And please do not keep working in either of those files when that's on, because all you're doing is you're setting yourselves up for problems down the road. In trying to reconnect everything, and you just don't want to go down there. This is the classic ounce of prevention is worth a pound of cure. And then the third one is these PCB design rules that you're going to get from the design houses, you want to set those up before you start doing your layout, not after. Because those rules are going to be enforced as you do your routing, and some routes may be valid at a very fine pitch, but if your house doesn't support it, or you can't support it here in the lab in creating your prototype, then you've routed something that can't be made. So you want to absolutely do that ahead of time. So there's a primary concept to think about with schematics and PCB layouts is that the schematic is what you're going to start with, which is here. And when you create a schematic, it's going to look something like this. So it's a bunch of symbols and connections between those symbols. And that describes the logical interactions, the logical connections between everything that you're doing on your board. The PCB layout is going to be very physical. So every one of these devices, for example, this MCP 9808, or this is the feather representation for a Zenon or an argon, is going to have a physical representation here, and that's a 1-to-1. And what's important is that they remain in sync, like I talked about, but once you get this done, then you can go down here and actually lay all this out and route everything and actually create your physical board from that. All right, so let's jump into Autodesk Eagle and do some schematic design and then do our printed circuit board layout. So what I've done is I've already launched Eagle. I'm running 932, as you can see here, and I'm going to create a new project. So over here in the projects area on the left, I can say new project, and I'll give it a name. We'll call it Temp Sensor. And then we can right-click on that and say New Schematic. So this brings up a new schematic editor, and this is where we'll actually do our schematic design. And of course, the first thing that we want to do is probably pop down some of our major components that we're going to connect, which really is just two. It's the MCP 9808, and it's also the Zenon. So right here is the symbol area, and this is where we're going to add a part. So if I click on that, it's going to bring up the library of parts that I have available to me. And if I type in, and by the way, this is going to use wildcard searches, so you need to put in a star if you want to have any characters before it to be valid. And then, like, I could say MCP 9808 and hit enter, and that is telling us that in all of those libraries that are there, there is no MCP 9808. And this is the story of my life. So essentially what you have to do is now go find the part if you can, or build it yourself. So one of the places that I love to go for looking for parts is Octopart. And the reason I like it is because it actually sources from a bunch of different suppliers, and it has a really good search capability as well. But if I search down here for MCP 9808, I see this is one of the parts that we have in-house here, and that's the one I would use. And I can come over here and I can see that it actually has CAD models for it. So if you clicked on Eagle, for example, I would get not only the symbol, but I would also get the layout for the PCB itself with all the pins and so forth. And then I even have a 3D model that I can include as well. So this is awesome. Normally I would just take this and bring it into the tool, but for the purposes of this video, I want to show you how you can do this yourself if you can't find the part that easily. So I'm going to close out of that a second, go back to here, and we'll cancel out of this. First, create a new library. So we can do that by going back here to our home directory right here, and we can say File, New Library. And in this library, we can create new devices, new symbols, new layouts, new 3D models, and so forth. So let me kind of take you through how this works. So a device is basically what you're actually going to put in your design, but a device is ultimately made up of a footprint and a symbol. And then those symbols and footprints get mapped together, and then every footprint can also have a 3D package that goes with it. And so those three things will define your device. So we would probably start out, well, first of all, let me, since we just did a file new, let me do save. And we will, in our libraries directory here, we'll call this WCL library. And now we have an empty library. And the first thing I might want to do is do add symbol. So what we can do is click add symbol, MCP 9808. And now we're in the symbol editor. Okay, so the symbol editor is pretty easy to use. What you're going to primarily do is first come over here and click on the pins, and you'll get this little circle, which is where you're going to connect to, and then the pin itself sort of going into the symbol. And if I, before we do that, so I'm going to just hit escape out of that, I want to bring up this guy, which I captured out of the so this was captured out of the data sheet for the MCP 9808, and we can see that it has 8 pins, and they're all labeled with these labels. So what I can do here is, we can just size this a little bit to use that, and we can go over back here, and we have our pin, and I'm going to stay oriented around the center point because I want the center point to be inside the part or the symbol itself so I can easily find it and move it. So I'm going to click here, 1, 2, and then maybe I want the alert separated and then the ground down here. And then on the other side, I want these to go the other way. So what you can do is come up here, pick the reverse. This rotates 180, and now we can do this side. And so I could do this VDD, and then maybe I'll put all these address lines together like that. Okay, so I'll hit escape. And looks like this wasn't quite perfectly aligned, so what we can do is go here on the group and select these guys, and then I'm just clicking the left mouse button once, and I'm moving it, and I'm moving it again, and so you can see I can just sort of move these around the way I want. The other thing is we want to also give the symbol an outline, so we can come up here, I've clicked on the little line here, and we'll be sort of right at the center. Come down, we'll click, 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 and click, and we'll hit escape, and we have now created our symbol. The next thing we'll want to do is give these better names. So we can go over here to the naming icon right here, where it has R2, and we can click on that, and then I can click on the pin itself, and we can call this one SDA. And we'll call this one SCL. We'll call this one Alert. We'll call this one Ground. We'll call call this one VDD, and then we'll do A0, A1, A2, and now we've labeled everything. Let me just save this. Now, two other things that you want to do before you finish up your symbol is put in name and value. So if I come down here to the names layer and I click on this and I do greater than name, then it will supply a name for us automatically. And we can put this wherever we want. Now, I want it kind of up here at the right, but notice how it wants to jump from one grid point to the other. If I hold down the Option key, which I'm doing right now, it will let me, and then I just click the left mouse button, it let me put it where I wanted it. So we just escaped out of that as we put that in, and then for value, we want to do the same thing. So we're going to come down here, and we're going to say value, okay, and again, looks like I can do it about right there, and I've done value, hit escape, cancel, and I've now really created my symbol. So let's pop out of that, and we're going to go back to our library here by just doing the table of contents, and we see now that we have our symbol. So before we do our footprint, I want to bring up the data sheet so we can see how this actually looks. So this is the part that we're doing. And we can see that it has all of these dimensions here, the size of the device itself, the size of the pins, the spacing on the pins. And you can imagine that this would be somewhat tedious to have to go in and do all of this manually. All right, so what we want to do is create this part in Eagle, and Eagle has a really phenomenal, easy way to do this. So we're going to start with this 3D package because we're ultimately going to create a 3D package from the footprint. So we'll go down there and click Import from 3D Package, and we'll say Create with Package Generator. Now what this is going to do is launch a website, or launch a connection, I should say, to their servers, and it's going to give us a bunch of choices over here for all the different kinds of footprints that we might want to start with. And I'm going to go down here to this one because ours is very similar to basically an SOIC package. So we're going to click on that. And then what we're going to see over here is a bunch of dimensions that are common for this type of format of chip. And then down here, we can fill in those values to do this. If we come over here and look at this, we can see that these letters over here turn out to match the letters over here, which is awesome. That's not true for all data sheets, so you have to make the conversions from what you see here to what you see on the data sheet based on their diagrams if they don't do it. In this case, they really helped us out by doing that. So the first thing we want to do is right up here at the top, our package is 8 pins, so we're going to change this to an 8. And then if we look down here, our pitch is unfortunately not 1.27, but if we look at E here, it's 0.65, so we're going to put 0.65 there. And the reason I say unfortunately is because the bigger the pitch, the easier it is going to be for us to deal with it in the lab. Now, bigger the pitch means bigger the footprint on your board, so that may not be ideal, but for things that we want to prototype here, you know, the smaller the footprint like this, the harder and a little more challenging it becomes. And then we have E here, so if we look at E is 4.9, so we'll just go in here and put 4.9 for these values. And then L here is 0.4, 0.6, and 0.8, so we'll do L is 0.4 and this is 0.8. And then B is 0.22 to 0.4. Okay, so B is 0.22 to 0.4. And then we have D, which is 3. And then we have E1, which is 3 as well. Now you could imagine if you were drawing all this in manually based on dimensioning it out, how much more difficult that would be. Now they do A1 and A2, but they don't give us an A. If we look over here and we look at this, we see A is from the bottom of the pin to the top. And if we go to the data sheet, bottom of the pin to the top looks like it is A2 plus A1. So it looks like we're going to do 0.75. They just didn't add them up, or I'm missing it. No, there is an A right here. Okay, A is 1.1. So we'll do A as 1.1. And then the A1, which is the smaller piece right here, is at 0.15. So 0 and 0.15. Okay. And we've pretty much got all the dimensions in. So at this point we can say update preview, and what it will do is it will go out and it will create the footprint and create the 3D model for the part all in one shot. So I'm just holding down the left mouse button and I can, move around. I can see the pads. I can see my 3D model here, and it's basically created this for me just by going with the data sheet and then filling in the values. So now I can click OK and click OK again. And we're good. So now what it's done is it's created a footprint, which if I click here, I can see that. The 3D package is here, and the symbol is here. So now I have everything I need to create my device, and I'm going to put these three together. So what I can do is say add device. We'll call it MCP9808. And in here, these windows always come in a little funny, but these are all the windows that we're going to fill in to create the device. So the first one over here is the symbol. So I'm going to click here, and sure enough, there's the symbol that I want. So I'm going to say OK, and I will drop it right there, and then I will hit escape to get out of that. And then over here, I want to add a footprint. So we can say new, and we can say add local package, and there is the local package that we just did. So since we only have one of them, I'm just selecting that, putting it in, and now it's added in the footprint and it's added in the 3D model. Now the final case right here is you see this warning sign. It's because we haven't connected the pins here with the pins on the device itself. So we can do that by clicking connect. And now that we've done connect, we can look at these pins and connect them. So again, if we go back to not this preview, but this guy, we can see that pin 1, here so the pins are labeled starting here, 1, 2, 3, 4, and then they kind of go around 5, 6, 7, 8. That's the standard. So I'm going to say, so SDA is the first one. So I'm going to click SDA and click 1 and click connect. And then I'm going to do SCL, and 2 is already selected for me, and I'll do connect. Be careful to not hit append. That's completely different where you're combining pins, and it can get very confusing. So the next one's alert. So we can select alert, connect. The fourth one is ground. We're already selected there. I can click connect. And then the fifth one, going back up the other side, is A2, A1, A0, and VDD. So now we've connected these symbolic or logical pins to the physical pins, and we click OK, and we get a check mark. And let's go ahead and click save. And we have now created a library, and we've created our first part in the library, and we have a 3D model for it. So if I close out of this, and let's go back to our temp sensor, and we'll do new schematic. Now, if I click on add symbol, and if I click on search, I now see it. So here is the library that we just created, and here's the part. So I'll select that, I have it here, and I can go ahead and drop it into our schematic. Again, I just clicked once, I hit escape to get out because I'm not going to drop a second one, and the part is here on the board or on the schematic. And of course, if I just click on that move or that little plus or crosshairs in the center, I can move the part around the way I want to. Now, at this point, I could save. So we've saved the schematic. Let's call it Temp Sensor. And the next thing up here at the upper left, I might want to create the board that is associated with it. And the way you can do that is just click this, say yes, create the board, and it's now created a board of a particular size. But notice over here, we've actually got a part. So if I zoom in, here's our MCP 9808, and that's the part that goes with this particular schematic. So once we've done this now, we don't want to close this, okay? If we have this, and then I click close, you'll see this annotation has been severed. This is what you don't want. So you don't want to have one open and the other one not open, because then they will get out of sync. So I'm going to just close this. I see them both here. And if I open up this guy, it's going to open up the board as well. So I'm pretty safe in that regard. Okay. All right. So if we're going to integrate this MCP 9808 with our Zenon, which is, we're really using a pre-manufactured board, sort of a dev board, and that's what we're integrating with. We're not actually integrating with the microcontroller itself. So we're not going to be searching for the NRF, 52 series of microcontroller. We're actually going to be putting something in that has the format of the Feather format. Now it turns out that Volterra, which is what we're going to use to build our board, has actually created a substrate pre-made for us for Feather type implementation. So if we go to the Volterra site at volterra.io, we go over to the store and we look at substrates. These are all the different types of substrates that you can get, but this one in particular is the one we're interested in. And that's what we have here in the lab. And so what this does is it has the Feather format with all the pins in the proper spot, and they all have rivets in them so that they are basically through hole. So the board can be just put in here and soldered on. And then what we're going to do is we're going to lay out any of our parts on this board. And it turns out, we don't have that many, so those will probably just go right here in the center, and we'll put them on this board as part of our layout. So this is the board that we're going to get from their library, okay? So if I go down here to Docs and we go to, Downloads, we can see that we have Substrates and Templates. And if we go to Substrates and Templates, we see that we have an Eagle library here already made up for all of these, which is awesome. So I'm going to just click on that and download that to the Downloads file. And then this is how we're going to add it into Eagle. So what I'm going to do is go to my Eagle's libraries directory, and then I'm going to go back into Downloads. And I have the LBR file here, which is how you know it's an Eagle library. I'm going to drag and drop it into this directory structure. And of course I already had one here, but I just took this one. This would be an easy way to update to the latest version if they do any revs to it. But now I have that library in Eagle. So unfortunately you have to click out of Eagle and then restart it, but we'll go ahead and do that. And it rereads what's in your library directory. So if I were to go up here to Library and open up my Library Manager, and I would look at what's available here, if I were to go down here to the bottom, I now see the Volterra library available to us. So we can say, this is something that we can say use, and by doing that, it will put it in the in-use area, and it will make it something that we can find. So now if I go back here to add part, and I click on add part, and I go down here to the Volterra community library, I see a bunch of different options for different substrates that we can include. The one I'm interested in is this template argon boron xenon, because it's the same for all of them. And so when we click on it, we see we have a nice symbol, and we actually have the board layout, including the outline and everything that we need for the substrate. So I'm going to click OK, and here I have it. And we'll go ahead and drop it, and I'll do an escape to get out, and cancel that, and I've now dropped that in. Now, if I were to go back to, let's save this, if I were to go back to the board as an example, we now see we sort of had two outlines here. The other thing is, if you don't like this black, it apparently defaulted to that for me. We can come up here to options and say user interface. And for layout, I can say white background. So I'm going to make that white just for me. And so now what we can do is go over here, make sure that we have everything selected. So I've selected that. I'm going to delete, 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 and delete. And then I'm going to select this guy and move it. I'm going to put it right on the corner there. And by the way, I'm using an external mouse, which I find more convenient than using the trackpad. So I would kind of suggest doing that if you can. And then we can take this one part and just move it inside. But we don't really have to do that now. I'm just kind of playing around here. But we now have our board looking more like what we expect to do for our final product. So I'll go ahead and hit save. And we're going to go back to the schematic. And now we want to finish this up. So I'm going to move this guy over here just so that we can connect some things easier, because SCL and SDA is on the left here, and here it's on the right. We can select both of them, move them more toward the center here. So a couple things that we need to make all this work. We're going to need VCC and ground, and we're going to need a couple of resistors. And we're also going to do an LED so that we can light up every time we do a reading if we choose to do that. So the way we do that is we go over here, and a lot of tools, other tools that I've used, they make it super convenient to do these very common symbols, and unfortunately Eagle doesn't do it that I'm aware of. So I have to go here, and we're going to say star 3v3 for example. Oh, that's Eve. It's not fingers in the right spot here. And we see in this supply one library, there are, if you were not searching down or filtering like we are now, there's a bunch of different options here. But 3v3 is a good one for us, so we'll pick that, click OK, and then we can place this wherever we want. So one of them is going to be here. Another one will probably be, let's say, over here, because that's where we're going to have our pull-ups for our I2C, and we have maybe something over here for the boron. So I'll escape out of that now that I've placed those, and let's go do this again. And this time we're going to do ground. So we've got supply 1, ground, that looks good. And we'll go drop the ground here, and we'll drop a ground over here. And that may be all we need on ground. And then we want to do some resistors. So we can go back to here, add a part. And to do resistors, we're going to want to go to the RCL library. So we're going to come down here to RCL. And we'll see, for example, these are capacitors and these are resistors. So here's resistors US. And it has a bunch of different resistors, some with 3D models and with different sizes. So our sizes are going to be 0805s, and here's an example of a resistor, but that's not the right look of the resistor. Let's keep going down here. Here's a resistor 0805, that looks correct. So we're going to pick that, and we're going to drop. Now the resistor's not the right direction, so I can right click and I can just rotate it. So let's just get these out of the way. I'm going to click left, hit escape, hit cancel, and I've dropped my 2 resistors in. So I'm going to select these guys and move this out a little bit so I have a little more room. I'm going to bring this up, and I'm going to bring these guys down maybe to about here and here. And I'm just going to bring this down to here, and then I want to wire these up. So over here is the net command. So you're going to click on net, and I am going to make that go to there and get this one connected to here, and then I'm going to get the other ends of those tied directly to 3 volts. So now we have 2 resistors with pull-up going to SCL and SDA. And we could give these values if we wanted to by going over here to the value icon, clicking on that, and then clicking on this, and we could say maybe 3.3 kilo ohms. And we could give this a value of, and now we've added a value in for those resistors. Let's see, we want to connect our 3 volts here. We want to connect ground. And we also want SCL and SDA to be connected. So this is SCL, so that's going to come up to there. And notice we want to see that dot, which tells us it's connected. And we're going to come up here and connect SDA. And let's go ahead and connect VCC, connect ground. And we're going to use the base address for this 9808 where these are all tied to ground, so we'll just tie these all. If you look at the breadboard for the Adafruit, for this implementation, they actually put pull down resistors on there, so it's all normally 0, but you could tag them high, which is kind of cool. But we don't need that versatility, and I don't want to deal with extra resistors on the board, so we'll just tie them directly. Now, alert is going to go into one of the pins over here. And so one of the things we can do is do a, you could just do this. And you're good, okay? So that's totally valid. But what I want to do, so I'm just going to back those out. Another way to do it is we can just bring this out a little bit and hit escape. And let's say we're going to set this to D4. Hit escape. We're going to create a label, and a label, if they match, is like a connection. So I'm going to come over here, and up on the top, I kind of like these bigger tags, if you will. So I'm going to click that, and then I'm going to right-click to turn it around, and then click left, and I've now added one. I'm going to go over here and do the same thing, and click again, and I've added one. And then I want to name them. So I'm going to go over here to name. I'm going to come back here, and I'm going to click on this guy twice, and I'm going to call it alert. And now when I do it again over here, and I say alert, it's going to ask me, do I really want to connect that net to alert, which I do. I'll say yes, and now these are connected. So what we want to do is look for an LED. So, and it's going to be a surface mount LED, and the ones I have in the lab are 0603s. So let's do star LED 0603, hit enter, and we look down here. Here's an LED, here's a chip LED. If I click on that, yep, that looks like what I want. So I'm going to click OK, and we'll have this LED here. And now we need to grab one more resistor. So since we already have a resistor on here, what we can do is say duplicate or copy. So I'll click copy, and I'll click on this guy, and I now have an extra one. See, this is where I feel the UX is just unorthodox for how you would normally do that. Normally you just select and then hit copy. And then we make sure our group selection is working. I'm going to grab both of these, and I'll just move them down a little bit. Say about right here. And then let's say that we're going to put this LED on D2. So I'm going to click this, and we'll go up and over and down. And then for here, we're going to connect to there. And for this LED is then going to go to ground. And then the only other thing is this is not the right value. This is probably more like a 200 ohm resistor. So I'll click on that, click on this, and say 200 ohms. And we'll have changed the value for that. So that finishes our first part for our introduction to Autodesk Eagle. We covered schematic design and creating a new part from scratch. And the next video, we'll jump into PCB layout.